Hello my dear students, this is Akash HD. Welcome to the AHD physics classes. Hopes you all are doing really great. So students, in this video we are going to solve the question from the chapter Gravitation, topic Universal Law of Gravitation. Basic question. See, the question is a small point of mass small m is placed at a distance 2r from the center O of a big uniform solid sphere of mass capital M and radius r. The gravitational force on small m due to capital M is F1. Okay. Now let's see. After that, what they are telling, see, a spherical part of radius r by 3 is removed from the big sphere as shown in figure. We will see next page. And the gravitational force on small m due to remaining part of capital M is found to be F2. The value of ratio F1 is to F2 is how much here? Okay. So let's see the situation. Here you can see very well. First I have taken here one original sphere is there, and what is the mass of the original sphere? Capital M. And at a distance of how much? 2r distance from the center of the sphere. Okay, so this distance is how much is given here? You can see very well. 2r distance from center, 2r distance we have taken one mass small m. Then according to the question, what is the force between these masses? You can see very well. According to the question, the force between them is what is given here? F1. Okay, attractive force, you know very well. After that, what is happening that here from this original sphere, given sphere, we have removed a sphere of radius how much? R by 3. Okay, so from here we have removed the sphere of radius how much here? R by 3. Is it? So this is called which one? From the original. When we will remove this sphere of radius R by 3, what will happen that here? This is the remaining sphere. Okay, and according to the question, what is the force between the remaining sphere and the point mass? They are telling F2. Is it? So we have to find out F1 by F2. Okay, and here you can see very well. Let's take the removed sphere is having the mass ms. Okay, then remaining sphere will be having how much mass? You know very well, m minus ms. Okay, is it? So here we are going to apply the principle of superposition. What can you tell? The force F1 or F2, which one will be smaller? You know very well, F2 will be smaller than F1. Why? Because force is the directly proportional to the product of the masses. So you can see very well here the mass is same, but here the mass is reduced. So as the mass is reduced, force will also reduce. Anyhow, F2 will be less than F1. But how to solve this? We will use the principle of superposition. So first one, we are going to use this original sphere. So force between the original sphere, how much here? You can see very well, F1. And you know very well here, this Newton's law of gravitation is applicable for the spherical bodies, point masses or spherical bodies, maybe hollow sphere, maybe solid sphere and all that. So total mass of the sphere can be concentrated here at the center and point mass small m is here. So what is the value of F1 due to the original sphere? Kindly see G capital M, and this one here is small m, and distance between their centers how much here? 2r here. So we can write here G capital M small m by 4r square. This one we have got it here. This is the force due to the original sphere. Okay. Now to get the force between remaining sphere and the point mass, what we will do? We will calculate the force between removed sphere and the point mass. Then this force we will subtract from this one and we'll get the F2 value. Let's see how we can see. So see, this is the removed sphere here, and let's take the force is how much here? Fs, or we can write here removed na, so Fr. Fr. What is the value of the Fr? Fr value we can write here, see, this Fr value. Now, force between removed sphere and the point mass is small m. So this Fr is given here G, and anyhow this mass m, and here ms. But can we get the value of ms from here? See the basic. So this mass of this removed sphere will be what here? The mass per unit volume into the volume of this sphere. That will give the mass of this removed sphere. Okay. So what is the mass of the original sphere? Capital M. And what is the volume? You can see sphere is there. No, so see please, m by 4 by 3. This is called the unity rule. 4 by 3 pi r cube. This is mass per unit volume of the original sphere. And what is the volume of this removed sphere? We can tell what is, see please, 4 by 3 pi. What is the radius of this removed sphere? You know very well, r by 3. Is it whole cube? So you can see very well what are the things will cancel out. You can see this 4 by 3 pi, 4 by 3 pi will cancel out here. And here you can see here r cube, and this r cube will also cancel out. So we can write here this ms will be what here? This you can see m, and what will come here? See 3 cube. That means it will become here 27. So the mass of the removed sphere, how much here? You can see very well ms value m by 27. So let me write here. This is the ms into m, is it? And what is the distance between the centers? See please, this one. So you know very well here, this is the radius r, total 2r. So from 2r, when I will subtract r, so it will become here what here? This is the r, is it? But now we want this distance. You know very well, this is r, and this distance how much here? R by 3. That means in r we have to add r by 3. So r plus r by 3 will become what here? This will become here 4r by 3. This is the distance between the centers of removed sphere and the given point mass. Okay, so here we can write here what? See please, 4r by 3 square. Okay, so let's simplify this here. G, ms value what we have got here by the unity rule, m by 27 into small m, and here what is coming here? Let's see, 9r square. 9r square or 16r square? 16r square, is it? So see 4r na, so 16r square by 9, is it? Let's simplify this. So we can write here, see, G capital M small m by 27 into 9 by 16r square here, is it? So let me cancel out this. 9 3 ja 27. So we can write here this, the force of this removed sphere, and the mass how much here? Let's see here, G capital M small m by, we can see here, 48r square. This is equation 2. Okay. Now to get the value of F2, we will use the principle of superposition. So we can write here, see, F2 means the force between the remaining sphere and the point mass, F2. So what this will become here? This will become here F original, that means F1 minus F removed sphere, principle of superposition. And again I am telling, the force between the remaining sphere and the point mass is equal to force between original sphere and point mass minus, because mass is removed. If mass is added plus, but mass is removed, so minus. So F1 minus Fr will give us what? F2. So F1 minus Fr. What is the value of the F1? You can see from the equation 1, G capital M small m by 4r square minus what is Fr? So see here please, G capital M small m by 48r square here, is it? Now what we can do here? We can just simplify this further. So we can write here, see, F2 equal to, just take the common, G capital M small m by 4r square. I have taken common. So what this will become here? See, 1 minus, and here it will become here, when from 48 you will take 4, so it will become here 12. 1 minus 1 by 12, is it? So what is this? See, G mm by 4r square. This is F1 only, na, F1. And after that, 1 minus 1 by 12 is what? 11 by 12. 11 by 12. So here what we can tell? Here we can tell very well, this F2 is coming F1 times 11 by 12, is it? So here if I write here, hence if I write F1 by F2 according to the question. So F1 by F2, if you compare this one and this one, F1 by F2 will become what here? It will become here 12 by 11. 12 by 11. See, this is the situation. And in the starting of the video also, I have told you very well, F1 is larger than F2 because here the mass is removed and force is directly proportional to mass, as I told you very well. See, what is this? F is directly proportional to capital M into small m here, is it? So what is happening that here, as the mass is removed, is it? Small m as it is, but this mass m, this mass small m we have decreased. So this force will also decreases there. And here you can see also, if in case F1 for example 12 Newton, then F2 how much here? 11 Newton, is it? If in case mass you will add, if in case any new question came, so their force will increase, is it? Kindly see very well. Very basic question. Okay, so which option will be correct here? The correct option is here, you can see 12 by 11. 12 by 11. So students, I hope so this video based upon universal law of gravitation basics is very clear to you. Keep studying, keep growing.